Hello. Today we're going to be having a look at probability distributions and discrete random variables, looking at some of the kind of questions that you might get, some simple ones, but also some that may look a bit more complicated and have notation that you're unfamiliar with, and a quick description of how to access those. Ultimately, this will help you attempt the questions on page 182 and 183 of the textbook. Again, as usual, I'll take snaps of these pages and send them through on the WhatsApp group. The questions that you have got range from very simple to some of the more complicated ones where you need to find various constants and such, so on, which I'll show you in a moment. But ultimately they should go towards helping you with the exam questions that have been posted on SharePoint in the statistics folder as well. So let's get started. This first thing here, this is what a probability distribution can look like. We can write it out as a table like this, and essentially all it's telling us is what's the probability of my random variable x equaling my value x. Now my value of x here, so I've got 5, 10, 15, 20, 25, 30. So what's the probability that x equals 5? Well, that's 0.1. What's the probability that x equals 10? Well, that's 0.2. So probability of getting 15, 0.1, and so on and so on. So this kind of notation here you should be familiar with from GCSE and from the work that we've been doing on probability in class so far anyway. But this table setup might be something that's a little bit new and different. It's not that scary, to be fair. It's just telling you the individual probabilities of each of the values. So first question here asks us to find out what the probability that x equals 30. So here we've got a blank box, but hopefully you should be able to use some of your understanding of probability distributions from GCSE, because very simplified versions of this kind of probability table and probability distribution functions you have seen before, but it might have had things like, say, beads in the bag of being like, say, red, green, blue, and it gives you some probabilities and asks you to work out the missing one. And you're then using the fact that you know that all of these probabilities add up to give you 1. So here if we add them up, 0.1 add 0.2 is 0.3, add another 0.1 is 0.4, and those two together will give me another 0.1. So altogether this here is 0.5. So from there to there we get 0.5. So that means that this final box here has got to be 0.5, and I'm actually just going to fill that in that box. So the probability that x equals 30 is 0.5. Similarly, we can use the probability notation that we've had before, except now we can start using things like less than signs, less than or equal to equal signs, for sort of one-ended inequalities and double-ended inequalities as well. So this one here, we want the probability that x is less than or equal to 20. So 20 is this one, 0.5. So you want to add 0.05. 0.05, add 0.1, add 0.2, add 0.1. So that's 0.45. So 0.45. All we're doing is adding together the probabilities of everything that's 20 and less, because it's less than or equal to. This one here wants the probability that x is between 15 and 30. So we're including 15 and we're not including 30. I'm just going to write down under here the things that we are including. I'm going to want the probability of 15 because it's included. I'm going to want the probability of 20 because that's between these. I'm going to want the probability of 25 because that's between these. I'm not going to want the probability of 30 because it's not equal to, so I want strictly less than 30. So these three probabilities are the ones that I'm going to add up. So if we refer back to our table, we've got 15, 20 and 25, so that's 0.1 and then another 0.1 with these two here, so that's going to give us 0.2. Now, as I said, these questions here are reasonably straightforward and you should be okay with these. These are mainly on page 182. The next set of questions are ones that look like this. Now, all of a sudden, we've still got this notation here that we're used to, but then all of a sudden we've got this odd looking thing here. So I'm just going to explain what all this is about. This here is what's called a probability distribution function. So a probability distribution function is just a way of using algebra to tell us how all of these different probabilities come together and work. So for example here, the probability that x equals, well, if I wanted probability that x equals 1, all I'm going to do is substitute this into my function. So this here is just like a standard old function that you would use for, say, plotting graphs and so on. So if I put x equals 1 into here, this is 1 over 2 times 1. So I'm actually just going to draw myself a very rudimentary table here, x, probability that x equals x underneath, and I've got values of 1, 2, 3 and 4. So I'm going to write there 1, 2, 3 and 4. So probability that x equals 1, so if I put 1 into here, I've got 1 over 2 times 1, so that's 1 over 2, so half. If I put 2 into here, I've got 1 over 2 times 2, which is 1 over 4. Now, I wouldn't put 3 in here because this function here is only for these values 1 and 2. If I'm trying to work it out for 3, I'm using this one, so this is 1 over kx. Now, you're probably looking thinking, well, what's k? It's a number that I don't know. And you're right, it is a number that we don't know yet. We're going to work out what its value is in a moment. So here, we've got x equals 3. If I put 3 in here, I get 1 over 3k. So I'm just going to write that, 1 over 3k. And if I put 4 in here, similarly, I'm going to get 1 over 4k. So 1 over 4k. Now, what we do know is, as with the previous question, that the probability distribution must add up to 1. So here, a half, add a quarter, add 1 over 3k, add 1 over 4k, must all add together to give me 1. So these things here, 1 half add a quarter, will give me 3 quarters. So that means that these two here must add together to give me 1 quarter, because 3 quarters add 1 quarter will give me the full 1. So I'm going to write that down here. 1 over 3k plus 1 over 4k must be a quarter when I add them together. So what we can do is we have an equation here. It's not a particularly nice one, but it's one that we can deal with using simple GCSE level algebra. I'm going to get a common denominator here of 12k, so I'm going to multiply this fraction by 4. I'm going to multiply the top and bottom of this fraction by 3. So I'm going to get 4 over 12k plus multiplying top and bottom by 3, 3 over 12k equals 1 quarter. So now if I multiply by 12k to get rid of the denominator here, I end up with 4 add 3 equals 12k over 4. Well, 12k divided by 4 is just 3k, isn't it? So actually here we've got 7 equals 3k. So I'm going to write that 7 equals 3k, giving me k equals 7/3. So now what we can do is we can substitute this back in here. So we can have 3 times by 7/3 is going to be 1/7. So this one here is 1/7. And then, 3 times by 7/3 is 7, which is why we get the 7 on the bottom there, so we end up with 1/7. 4 times by 7/3, because it's 4k, so 4 times by 7/3 will be 28/3. So this is going to be 1 over 28/3. Well, 1 over, we can do the reciprocal here, so we can just write it as 3/28. So my probability is for 1 it's a half, for 2 it's a quarter, for 3 it's a seventh, and for 4 it's 3 over 28. The next one then asks us to, says hence find the probability of the x's between less than or equal to 4 but greater than or equal to 2. So if we think about what we want to find here, the probability for 2 is what we will want because it's greater than or equal to 2. 3 we're going to want, and 4 we're going to want because it's less than or equal to, so 4 is included. So for here, the probability x is bigger than or equal to 2, and smaller than or equal to 4 is going to be, probability for 2 is a quarter, add the probability for 3 is 1/7, add the probability for 4 is 3/28. Now again, all of your exams here are calculator, so you can actually just type that into the calculator. I'm going to do it without, so I'm going to multiply top and bottom of this fraction by 7 to give me 7/28, multiply top and bottom of this fraction by 4 to give me 4/28, and I've got my 3/28 there. So 7 add 3 is 10, add 4 is 14, so 14/28. And those of you who are being really clever should hopefully have looked at the original distribution function and thought, well, if I want to add these 3 together, I can actually just do that by taking the one that's missing off 1. So 1 take away a half is a half, which is what this fraction here simplifies down to when you add them together. Doesn't matter which way around you do it. If you were to add these 3 together and get to a half, you'll get exactly the same number of marks as if you were to be quite clever about it and take 1/2 off of 1, which is all of these probabilities added together. So again, you should be looking at page 182 and 183 in the textbook, and as I say, I will drop some snaps of those in the WhatsApp group. If you've got any questions with those, please do drop some questions in the WhatsApp group. One note, however, just to finish off, for the questions on the SharePoint website, if you have a look at the exam questions, you will see things that have this in them. You'll see things like that, and you'll see things like this. So this here is wanting you to find the expectation or the mean of the probability distribution function and the variance of the probability distribution function. Now you hopefully will remember mean and variance from the things that we've been doing recently. However, on the old syllabus, these things were required. You were required to work these things out. But on the new syllabus that you guys are studying, you are not required to work out the mean and the variance or the standard deviation for a probability distribution function. So you don't need to be able to do those. So if you come across questions that say e of x, or var of x, then you can ignore them. Similarly, any kind of transformation, so if it sort of introduces a new variable y and tells you that y is 3x minus 2 or anything like that, you don't need to be able to do any of these transformations, because the whole point of these is to then test your understanding of how that impacts on the expectation or the mean, and how it impacts on the variance. And so any questions that look like these, you can ignore from that pack of questions. Just have a go at the ones that look like these, where you're asked to work out maybe a value of k like a constant, or work out some individual probabilities. That's as much as you need to be able to do on the new syllabus.